our dear guest for the last several years on this conference, Marian Marinov of Bulgaria. He will talk about writing and building Apache models.
Okay, so thank you for staying for my talk. First of all, this talk was, the idea for this talk was to start you for building Apache modules. Because for the past 3 years, I have built 13 different Apache modules, and what I see is that there are not many new modules added to the Apache library. This means that there are not many developers of Apache modules. And Apache modules can help you ease your development or increase the performance of your applications without a lot of writing and simplify some of your stuff. So what I wanted to do is a simple talk that will present you with the beginning of writing an Apache module. How many of you are C programmers or know C at all? Okay, so it will be easier. First of all, I want to start with how Apache handles its requests and what steps it takes, because in each step your module can help or do something for you instead of your software beneath Apache. So this will work inside Apache and work faster. Then I'll talk about how the memory is handled within Apache, which is a little bit strange. And then we'll show one module in Apache. So what you see here is 13 different steps, 10 different steps, I'm sorry, that are done for Apache 1.3. I know this is an old version of Apache and it's not current at all, but the same idea goes to all Apache web servers. I'm starting with Apache 1.3 because it's still the fastest of all of them. So you can start with just after reading the request, getting all the request text at Apache, you can start and test this, read it, parse it, whatever you want to do, or even log it. Then you can resolve the file name. This means that from the URL, you translate the URL to a path within your file system. This is what Apache does at this step. And this is useful when you have virtual file storage, when you want to map a file that is located in different place on the file system directly to a file that should be served to the client. This is very easy at this step because you can simply change the destination file. It's like a rewrite rule, but it's a lot faster here and a lot flexible because you can map different things without outside software. Then you have the step for parsing the headers. At this stage, you see only the headers of the request. This is useful when you want to change headers, or you want to simply do different tasks based on the request headers. Then you have to check the access. If you have HTTP authentication of any kind, at this stage you check the authentication, and then okay, I'm sorry, this is only for IP network checking, host names and IPs. The next one is for authentication, and the step after that is only if you have a user and it has been authenticated, you can do additional tasks directly from the module. After that, Apache is checking the MIME type of your file. It's based first on the URL, and if it cannot resolve it through the URL, it checks the file name that was given from the second stage. Then you go to the generic fix-up stage. At this point, you can do whatever you want. but everything else was already done. So you have a file name resolve, you have MIME type, you have authentication, so you know that all of these steps have been done, but you can do additional checks. For example, at this stage, you can check if you can prevent a simple attack on Apache when a user can request a symlink to a file that he doesn't own. This is a very common attack in shared hosting. So at this stage, usually guys implement a module that checks if the destination file is owned by the same user, and if it's not, they deny the request. At this stage, if you have modules for handling different types, for example, mod PHP, mod Python, mod Ruby, mod Rails, you can have, you map the MIME type to the function that will actually execute this script. And the final step is if you want to change the logging. For example, the normal logging is in file. If you want to log in a database or on a remote place, you can configure, you can write a module that can do this for you. With Apache 2.0.22.24, you have two more types, two more steps. Map to storage is, again, it's after resolving the file name. This is the stage at which you can actually change the file name that was requested. This was introduced because first, this second step maps a URL to a file name, but additional modules can change the file name, and then after that, you can map this new file to a new storage. And the insert filter is a very nice feature for filtering requests. Something like if you want to have your own mode security module, but a little bit wider and with rules only for your application, usually the insert filter is the best place to go. So, how Apache handles the memory. Firstly, you know that in C you have to allocate your memory by yourself. You have to handle allocating and freeing this memory. And the problem is that Apache has different types of setups. Sometimes it can fork, sometimes it can use threads. So basically your module cannot know in what type of architecture it is running at the moment. And for you, this means that you don't know how to allocate and free the memory without actually having issues with the memory. So Apache creates a memory pool that is allocated for all modules within Apache, within its child process and its master process. And at this memory pool, your module requests memory. So you don't have malloc and free functions. You actually have up_alloc, which is pull alloc. And for Apache 2 and newers, you have APR palloc. As you can see, you don't have free here. This means that Apache is handling freeing of the memory for you. Some modules, like mode PHP, are notorious for not freeing its memory at all and relying on Apache to free the memory, which actually is not a very good idea because the memory is only growing until the process is killed. One other thing is that in Apache 2 and newers, you have most of the string functions like str copy and duplicate string and functions like this that are actually implemented within Apache directly, and they use the internal Apache memory pools instead of their own memory allocations. Okay, The next thing is how your module will actually operate. Your module has to have some options usually, or it's not required, but usually you have some options. Do you want to have your module enabled or disabled, or do you want to have a log file and stuff like this? Then you want to have your module register in access tables, meaning that your module should accept a request or doesn't or would not accept that request. Also, your module can register and in the authentication tables where you have multiple modules that check for authentication, and the final table is handlers, which means that these all four are different tables and at different stages of the request. These tables are walked through one by one the lines, and the first match is the thing that actually handles your request. If you have an option here that is defined by two different modules, the first module that actually defines this option will handle the value of this option. If you have more access modules, they will be checked, and the first module that gives you a decision, deny or allow, will actually handle this request. This is the same for authentication and handlers. So how to start? Usually you would go directly to mode example, which is shipped with each version of Apache. And what you get is this file for Apache 1.3 or this file for the newer versions. At these files you will see a lot of lines of code, a lot of functionality that you will not use. The problem is what you want to understand what you want from these modules. Usually the best case would be to find a module that has a similar functionality to what you want, look at that code, and also read the comments in the mode example to help you understand more about what you want to do later. The next thing is to know which include files you need, because even if you copy directly some code, it's not 100% sure that this code will work at all. And in most cases, what you have is a problem with include files, and no one knows which include files does what. So the basic structure of a module includes first some library files, then you have the module name, then you have additional module definitions where your module actually works at each of the four tables. Then you have, you define module comments if you actually have any comments for your module, and the final thing is to handle the configuration. So I'll start with includes here. HTTPD.h is something like stdio.h for a normal C program. This includes the main structures of Apache, includes the connection strings, the handling request structures, most of the things that you would need in any of the modules. Then you have HTTP config. In this one, you have functionality that allows you to parse different functions within the configuration file. If your module doesn't have any options, you don't need configuration functions. But your module should do something with the actual request or something with the protocol, and these are the headers that you need. The protocol itself is needed only for applications that, for modules that use, would change the request on when it first comes to the server, when it is actually accepted to the server. This is very rare to be seen, but there are functions here that allow you to change the data even before the first option of the first pass of parsing the request. You have a lot of other includes. The main thing here is HTTP main that is used for handling different, how many Apache servers that you, how many childs you can build, how many servers you can start with different workers. For example, if you're with worker or with pre-fork for Apache 2 and newer. And there are a lot of other header files. You should have them when you are building Apache modules. Obviously, you need them for the build, but I advise you to read the comments in these header files because they give you a lot of hints about how to use the information there. And there would be information what you see in the actual requests or connections. HTTP log defines the functions and how they work in different Apache versions. You'll see later how this changes. Obviously, you have a lot of other modules, a lot of other headers. If you want to write a portable module, this is my way of writing portable modules between 1.3 and 2.0.2.2. I usually define Apache 2 as define string, and then I use it for all the code that I'm using, for all the portable code that I have in my modules. Apache 2 is actually defined by checking in the source code in different versions if there is particular string. If someone is very interested in importing, you can come to me after the talk and I'll explain this with a little bit more code. So the module names here, this is how you define a module name for Apache 2 and newer, and this is a little bit different for Apache 1.3. Now the module definition, I'll start with Apache 1.3. These numbers here represent the Apache handling structure, the handling request that I show you 1 to 10 in the beginning. So when you define a module, you have to include this standard definition. It includes some libraries from Apache, and then you here you post your function that will initialize your module. Usually, this is needed only for two things. One is to add your version to the banner of Apache, or initialize something that should be shared between all of the childs of your Apache server. Something like if you want to have a shared memory between all of your modules, this is the place to have a function for that. Then you have 4 functions for configuration, which I will explain a bit later. And this command table here represents a structure of your options and their explanations, plus the functions that will handle these options. This here is, again, a struct of handlers and the functions that will handle these handlers. And by handler, I mean application / x HTTPD PHP, for example. This is a handler. CGI-script is, again, handler. Text / plain is again handler, and you define for each handler different function to handle it. You can handle it directly with pulling the file from the file system, or you can have a more complex function that will actually do something with this information before pulling these files. Then you have a function that will be used for file name, URL to file name translation. This is the second phase when you map the file to the URL to the file. Then you have function for validating the user ID. You have a function that is run executed only when the user ID was valid, user ID and password were valid. Then you have a function that can check for IPs. Here, usually, you can see modules like motout MySQL or motout PGSQL that are used for checking the IPs directly from a database. Obviously, the two modules that I mentioned were for authentication for the users, but the same logic applies for IPs and host names. Also, then you have the function for MIME types, fix-up, stage. This is your function for logging, your function for header parsing. And this function is initialized only when the process is started. This means each time a process is started, each time a child of Apache is started, a thread of Apache is started. And okay, for this here, this is a child of Apache because it's Apache 1.3. And then you have a function for handling the reading of the request. In Apache 2.2 and 2.4, this is a little bit different. The first definition of the module is simplified by adding only the standard stuff, the configuration, the command table, and then you have the processing hooks. The processing hooks is a different function in which you define all the other 10 stages of the request, and actually you have additional things like the insert filter, the map to storage, and additional functionality. Oops, sorry. There is a big difference between 1.3 and the newer Apaches in the way that the modules are loaded. With Apache 1.3, it's required that the modules are ordered by the way they're loaded in your Apache configuration. In Apache 2 and newer, you have this functionality where you can say these modules have to be loaded before or after my module was loaded. This way, if you have multiple handlers for the same MIME type, you can say that your module will always handle this MIME type instead of the other module. Oops. Okay. So the initialization with Apache 1.3, every time when you add your initialization function every time when your Apache is started, your initialization function is run twice. You have to check for that when you're implementing shared memory, for example, because the second time you would already have a shared memory allocated and you have to check for that. This is a strange situation that was never fixed in Apache 1.3. In Apache 2 and newer, you have this situation split in two. You can load your initialization stuff before reading the configuration or after reading the configuration. These are the two ways. So this way you can be sure that your initialization of Apache Web Server has been done only once, and you can be sure that you either have configuration or don't have configuration. With Apache 1.3, it depends. So for configuration directives, you usually have configuration that is defined within the module, and for these configurations, you should have memory structure that will handle your actual module options. Then you have to define some commands that we will see. These are the actual options, and you have to define the functions that will handle the text that is in the HTTPD configuration and parse it to something that will be used by your module. The structure usually is pretty simple, something like this. You define some type of element, and this is the structure that you use. After that, Okay, for arrays, I will get back to that a little bit later. After you have defined this structure, you have to define your option. For example, my option should be called example here. The function that will handle my option will be called CMD example. I would not send any arguments to this function directly. I will send only, in this case, I will check only for the existence of example in http.conf. And here I say where in the configuration my option should be, and that my option example would not have any options after that, any arguments after that. For example, you can have server name, which after server name obviously have the server name, but in my case, after example, I don't have any arguments. This is the explanation for my arguments list, for my example option, and finally this list should end with a no. If you don't no terminate this list, your Apache won't start. Sometimes may start, but it's a little bit different situation. Okay, with Apache 0.2 and newer, this structure is only renamed, okay, because no args here is the same as no args from here, and the difference is only this structure type. With this no arguments, here I have outputted the list of all options that you can say. So you can have option that takes a flag, meaning on or off. You can have option without any arguments. You can have option that can read the actual string from the option after that. You can have option that have only one argument, option that have two, option that have to iterate over each of the options that arguments that you have to the option and to the end. Again, for the configuration, here we have different stages where your options should be available. This is, I think that all of you know options and all override in Apache. This is how you handle your option. You decide that you want to have your option in the configuration file itself only. You can have your option in the configuration file and also in directory and location box. This is different than the main configuration because the basic configuration of Apache, the basic HTTP config, is split in three parts. The global configuration, then you have virtual hosts configuration, and the final part is directory and location configurations. Each of these parts is parsed separately. So after you define here where your options should be available, you have to handle how they should be parsed when they overlap. For example, you have one option in the global configuration and another option in directory configuration for your file. How they should be merged depends on you. You have to define function that can handle these merges. So the function for reading the example option looks like this. You define a name for the function, depending on the number of arguments that you have. For example, take one, take two, iterate, or no arguments. You would have this argument here or not. You can read this information in the example module and copy the prototype of the function from there. There is a little bit difference between the configurations. So vconf that you see here, this is handed to the function when you're parsing the HTTP config. By default here, this is the directory config, which means that in this case, here you have, if you can check the CMD parameter here and check for the path from this structure. This was used to see the file, but now it's only used to check if this is a configuration from within the directory or from the whole server. So if the path is null, you have a directory config, and you can replace it with the server config from here with this simple function. Then after you have a configuration pointer, then you can attach to this configuration pointer to the option of this structure your argument that you have read from the configuration file from here. Did I explain that at all? Maybe not. I'll try later. So I already told you that you have 3 different configurations, global and virtual hosts. You have to merge the configuration. So first, Apache parses the whole configuration file. It looks for the global configuration. It creates a configuration structure, and this is only the global config options. Then you have virtual hosts within this configuration, and these virtual hosts include additional options. They usually overlap with the default global configuration. So you have a function that decides, would you like to have the option from the virtual host or option from the global configuration? This is based on your module. Then you have the per directory configuration, which is used only when you are accessing a file directly. So after you the request have found that you are in virtual host or in the global configuration, then you see the configuration from the directory, which again has to be merged within with the other configuration from the global configuration file. And the initialization of the configuration is usually the first step. After you know that you have to merge your configuration files, you should first initialize your structure for your module. The first thing that we did, example conf structure, you should initialize it with zeros or whatever options you would like for your module, and then with your merge functions, you would merge the configuration from the HTTP conf. The final step here is logging. After you have created the configuration, wrote the name of the module, created options, handled them, and the final thing is to log your information. You have 2 functions that are mainly used in Apache. First is the log error function that is directly used with the server. You usually should handle the server pointer to this function, so Apache would actually know which child actually handles your request, and which file descriptor should be used to write your message. And the other is to use the request itself, not the server, to identify the file descriptor to log to. In Apache 2, you have additional error functions for the connection, for the connection, and for additional errors that are handled. Usually when you are starting Apache, you don't have open to log files, so you cannot log information there. I advise you to use fprint at this point and use it only while debugging and developing your modules. After that, it's not very advisable to use fprint in live modules. And in addition, with Apache 2, you have to add the status of your message if it is actual error or if it is a simple info notification to your log error or log error functions. Yeah, the porting trick, you can if this is not defined. This means that the code is not Apache 1.3. And the other thing, if your module was written for Apache 1.3 in Apache 2 and your function should be called APR. Some of the functions also, functions and structures are changed from AP to APR. You should read this documentation here for newer modules, and if you really like writing Apache modules, I advise you to read this book. So, if you have any questions.
Any questions? Somebody writing Apache models?
Okay, first thing that I did was a simple module that combined 3 different modules in Apache that were using for, they were used for load balancing, for connection limiting, and the other I don't remember. When you combine 3 different models in a single module, actually your request is handled by one module, so it's handled a lot faster than 3 different. This was the first thing that I did. Then I had an application that required to read the files from directories directly from web, but usually you would have an API that reads the directory and creates a JSON structure that you read for your application. Instead of reading the files with additional API handled by mode CGI, by SUEXEC and stuff like this, I simply wrote a module that reads the directory structure and sends it to me in JSON format. Last year, I had this situation where Apache was not patched for the range attack for more than 2 weeks, and I wrote my own implementation for to protect my servers, because I handle a lot of servers, and I mean thousands. So unprotected servers was not a good idea more than a week. And you can think of a lot of different applications. You can simplify your authentication, you can simplify your access configuration for your applications. I don't know what is your case.
Another question?
Is it possible to track which modules in Apache use which amount of memory? So, for example, we have Apache process which keeps to grow and we don't know which module is that.
Yeah, it is possible. You can dump the contents of the memory pool. You can actually search through it. I don't advise you to do this on a production environment, but in a development environment, it's easy. And actually in Apache 2.4 and 2.2, you have additional modules that can say how much memory is used by the whole request, only the request, and each module's through it. Also, you can log the I/O information for all of the requests. The I/O was walk I/O, but the other one I don't remember. It is development module. It's not in the standard build, so I don't really remember it. But we can look it up.
Any other questions? Thank you very much.
Thank you.